Hey there, everyone. Ryan Schul here. Welcome to my channel, Straight Data Science. So in the project today, I want to look at list comprehensions, dictionary comprehensions, and show you how they have very similar looping counterparts. So there's a loop equivalent to a list comprehension and to a dictionary comprehension. So let's jump into it. So the advantages basically are conciseness. You can write the entire quote unquote loop on one line. And normally a typical loop could take 3 to 5 lines. It could take even more, right? So everything is condensed and compressed into one single line. It's very readable. It's very efficient. It's actually a little bit faster. I wouldn't say like significantly faster, but at least marginally faster than a loop when you use these type of comprehensions, right? So more readable, more readability, more performant. Also, like just cleaner data pipeline concepts, right? So in the data processing or data transformation, if you're doing ETLs or something, a list or a dict comprehension allows for cleaner chaining and basically easier functioning style programming. So let's take a look. I just have a few samples here, and this is going to be a very short video, by the way. So if you only have like 5, 6, 7 minutes or whatever, I think this is time well spent. So here's the first example of a list comprehension. We are basically using loop off to the right. So in a typical loop, you start with the for something in list, right, or in range. The loop actually comes at the end here, and the list comprehension comes at the beginning. So you have x double double 2. So we're squaring this list. Now here would be the typical loop. All the items would be appended into this list right here. The list has square brackets. It's called squares. For x in range 5, square append x double double 2. So we're squaring all the items. All right, here's the loop, and here's the list comprehension. Let me run it so you can see what the result is. So we get exactly the same identical outputs, right? So let's look at another example here. We can filter even numbers from a list. So again, here's the list comprehension, x4, x in range. So here's the loop part, for x in range, right? But here comes the list comprehension part. If x modus 2 equals 0, so you're dividing by 2. If you can divide the number by 2, we're going for x in range 0 to 10, or 1 to 10, I guess. No, 0 to 10, right? 0 to 10. If that number is divisible by 2 and the result equals 0, then we're going to insert that into this even list comprehension. Here's the loop equivalent. Here's the list, right? For x in range 0 to 10, if x modulus 2 divided by 0, or I'm sorry, if x modulus 2 equals 0, then append to x. So let me run it, Control Enter to run. And again, we see identical results, outputs. So we can create a list of tuples. Okay, another list comprehension example would be x comma x multiply 2. So we're squaring the x's for x in range 5, right? So here's the looping part, right? Typically in list comprehensions, it comes at the end, and the comprehension part comes at the beginning, right? So we're going to create tuples here. Tuples consist of items in a list for x in range 5. Tuples append xx2. So we're creating a list of tuples inside, or creating 5 tuples inside of the list. So tuple 1, tuple 2, tuple 3, tuple 4, tuple 5, and this is a list. And again, we get identical output, right? So we can flatten the 2D list. Here we have a matrix. So we have a list of lists. Here's the first list. Here's the second list. Here's the third. And all of these are contained inside of a list. So we can print the matrix and flatten it. Num for row in matrix. Again, the loop comes towards the end, not the beginning. For row in matrix, for num in row, and we're going to take that and flatten it. Now the alternative loop equivalent would be flat equals list for row in matrix. Okay, here's the matrix, for row in matrix, for num in row, flat dot append num, and then we're going to print the results. And again, we're printing the original list, printing the matrix. This is the matrix, and let me put a separator in there, just to make it a little bit easier to read. Okay, there. Control Enter. Okay, so we have the matrix, and we have 2 identical lists underneath. So here's an example of how to use dictionary comprehension. Okay, it's going to be very similar to a list comprehension, except it's a dictionary object instead of a list object. For x in range 5, we're going to square x, and we're going to insert everything into the list comprehension called squares. Here is the dictionary equivalent. And here's the loop for x in range 5. So 0 to 5 squares, x squared. So 0 squared is 0, 1 squared is 1, 2 is 4, 3 is 9, and 4 is 16. Okay, so there's the dictionary. And you can see this is a key value pair. This is a key value, another key value, one more, and here's the final one. Okay, so we can filter only even numbers into a dictionary. Again, list comprehension for x in range 10 if x modulus 2 equals 0. So if the number 0 through 10 divided by 2 equals 0, we are going to insert that into the list comprehension. And over here, we have a dictionary for x in range 10. This is a loop if x modulus 2 equals 0. So if 2 divided by 2 equals 0, go ahead and do the append. If 4 divided by 2 equals 0, this is even number, then go ahead and do the append, control enter. And here we have the dictionary key value pair, key value, key value, key value, key value, and key value. Okay, so just like I promised, getting close to finishing up here. It's pretty short. Dictionary comprehension, again, we have pairs. A is paired up with 1, B with 2, C with 3. Dictionary from pairs, K to V. This is the key value pair for K. Given V in pairs, then insert into the dict from pairs. And here's the loop equivalent. So here's the dictionary for KV. There's two loops here, K and V in pairs. Dict from pairs, K equals V. Then insert that into the dictionary, right? We're not doing an append. When you have lists, then you have append, right? Flatten append. This into the key value pair is just doing an insert. And where are we? This item right here, right? So here's the final dictionary, exactly the same, just dictionary comprehension versus loop. So let's compare these two items now, or these two concepts now, using performance type of metric, right? So we're going to see how long it takes to go ahead and run a list comprehension versus doing exactly the same thing using a looping methodology, right? So we have the start time, square comp. We're taking numbers and squaring them for x in numbers. Computational time equals time minus the start time. So we have the start time, this is the end time, and the compute time is that. And here we have the start time, end time, squares loop. This is a list object for x in numbers. Here's the number for list in range 1 million. So we're going to loop 1 million times. Square all the items time end minus time start equals time to complete. And we'll validate both methodologies, right? The list comprehension and the loop. So the list comprehension took 1.018 seconds and the loop took 1.39. So I know what you're saying, not a big difference. 0.39, about 0.38 seconds different. Like nobody's going to lose any sleep over that, right? But if you can imagine much larger, we can do this 10 million, or if you can imagine a much larger, much longer running process. Now we just shaved off 0.39 seconds, not even 1 second, right? We didn't even save a full second. But if you're doing large operations, they're very computer intense, CPU intensive, and it just runs for hours on end. And you can use the list comprehension, which is more efficient. It could save you several hours of time. Now the time is basically cut in half. The count from 0 to 10 million, the list comprehension took 3.72 seconds, and the loop took 6.48 seconds. So already it's doubled in time, right? And I'm sure you can imagine, put your thinking cap on, and imagine a bigger, more compute intensive task. And you're talking about hours, right? Hours of savings. So here's the list comprehension, 0.83 seconds, 0.98. Again, we did 1 million iterations. If you input that or bump that up to 10 million, you'll see a bigger delta between the two, right? The list comprehension starts here, and the loop, the traditional loop with append, starts down here. So 2.92 seconds for the list comprehension, 5.18. So not quite double, maybe 1.8, whatever this is, 1.8, something like that. But definitely took longer, right? So you can see the obvious advantages here. List comprehensions operate like a loop. However, it is typically faster, and it's typically easier to read and to explain to other people, although there are exceptions. Sometimes if the loop is very complicated and you have several nested conditions or loops within loops, and you have conditional loops or nested loops, the loop might actually perform better in some instances, and it might be easier and cleaner to read if these concepts get extremely complicated. You might want to go with a loop. It's really up to you. It's really case-by-case basis. For debugging and logging, it might be easier to add print statements to a loop and to see what the outcome is versus using list comprehension, right? And just for working with multiple objects, again, if it gets very complicated, maybe a loop is more appropriate than a list comprehension. Really, it's case-by-case basis. I will leave that up to you to make that determination. But I just wanted to introduce the concept and show you how it works, just so you have another tool in your toolbox as a data scientist or ML engineer or AI expert or whatever it is that you're doing, just so you're aware of this. I think more knowledge is better than less knowledge, okay? So I promised a short video today. It actually went to 10 minutes. Sorry about that. Apologies. But that's it. I'm going to wrap it up here, and I will see you guys in the next video. Talk to you soon. Bye.